Welcome students. Let's begin with the next session of organic chemistry in which we are going to cover alcohols, aldehydes and ketones. So let's begin with alcohols. Alcohols is that class of organic compounds in which the carbon atom is attached to a hydroxyl group. In case the hydroxyl group is attached to an aryl group instead of alkyl group, then the alcohols are known as phenols. So they are considered as the hydroxyl derivatives of alkanes. Their general formula is ROH, where R is the alkyl group, or CnH2n plus 1 OH, where N is an integer. On the basis of the number of hydroxyl groups and the alkyl or aryl groups present, we can classify alcohols into aliphatic monohydroxy alcohols, aliphatic dihydroxy alcohols, aliphatic polyhydroxy alcohols, aromatic alcohols and phenols. We can then further classify monohydroxy alcohols into primary alcohols, secondary alcohols and tertiary alcohols. So let's begin with the basic characteristics of each type of these alcohols. So the first type of alcohols are the aliphatic monohydroxy alcohols. As the name itself suggests, it has an aliphatic group and a single hydroxyl group attached to a saturated carbon atom of the aliphatic group. Aliphatic monohydroxy alcohols are further classified into three types: primary alcohols, secondary alcohols and tertiary alcohols, which are also referred to as 1 degree, 2 degree and 3 degree alcohols. In primary alcohols, the hydroxyl group is attached to a primary carbon atom. In secondary alcohols, the hydroxyl group is attached to secondary carbon atom, and in tertiary alcohols, the hydroxyl group is attached to tertiary carbon atom. So if we look at these examples, this is the example of a primary alcohol where R represents an alkyl group. As we can see that the carbon atom is attached to only one other carbon atom and therefore it is primary in nature. In secondary alcohol, the carbon atom to which the hydroxyl group is attached is further attached to two carbon atoms. And in tertiary alcohol, the carbon atom to which hydroxyl group is attached to three carbon atoms. That is the maximum possible number of carbon atoms. Those alcohols which consist of two hydroxy groups are known as dihydroxy alcohols. For example, ethylene glycol, propane 1,3-diol and propane 1,2-diol. Aliphatic polyhydroxy alcohols are the next type of alcohols in which more than two hydroxyl groups are present. For example, in glycerol, there are three hydroxy groups found. After aliphatic alcohols, the next type of alcohols are the aromatic alcohols. These alcohols consist of a hydroxyl group attached to a side chain of an aromatic compound. For example, benzyl alcohol and 2-phenyl ethanol. The last type of alcohols are the phenols. They are different from the aromatic alcohols in the fact that in phenols, the hydroxyl group is attached directly to the aromatic ring and not to the side chain. For example, phenol, benzene 1,2-diol and benzene 1,2,3-triol. Phenol is considered as the representative member of this class, hence this class itself is known as phenols. Now let's have a look at some of the general methods of preparation of alcohols. The first method of preparation is from haloalkenes. Haloalkenes are hydrolyzed to the corresponding alcohols by treatment with aqueous alkali. Primary haloalkenes give a good yield of alcohols, whereas tertiary haloalkenes are converted mainly into alkanes. Secondary haloalkenes give a good mixture of alcohols as well as alkenes. The second method of preparation is from aldehydes and ketones using Grignard reagent. Aldehydes and ketones are converted into alcohols by reaction with Grignard reagent, which can be represented in general by the formula RgX. This method is used to prepare all the three types of alcohols. The reaction of Grignard reagent with formaldehyde gives a primary alcohol. Use of any other aldehyde will produce a secondary alcohol. But the reaction between a ketone and a Grignard reagent yields a tertiary alcohol.